Hey guys, we're going to look at solving a system of equations that has three variables. We're going to add in the variable z. Sometimes it'll be different letters like a, b, and c or something like that, but x, y, z is common. So the hardest part about these is keeping yourself organized. So the way I'm going to show you, we're going to split up, and yes, this is going to take a lot of paper because it's a lot of work, but we're going to split it up. We're going to make 6 boxes. So the first thing that we're going to do after we set up our boxes, 6 boxes for the entire thing, we are going to label our equations 1, 2, and 3. We're going to do like Roman numeral 1, 2, and 3, kind of follow a little bit of like a outline notation here. So equation 1, equation 2, and equation 3. So our next step once we label them is we're going to pick 2 equations, and we're going to cancel out 1 variable. You can pick any 2 equations that you want. You can pick any variable that you want. We're just looking for ones that will be easy to cancel out. So let's go ahead and cancel out the, let's do z. That's pretty easy to cancel out here. So to cancel out the z variable, we're going to use equation 1 and equation 2. And to make them cancel, we can't just add them because they won't cancel then. We have to actually subtract them. So let's do equation 1 minus equation 2. So that's going to look like equation 1, just keep it the exact same. Equation 2, we're multiplying it by that negative so that the z's cancel out. We have a positive z and a negative z. So multiplying by that negative gives us negative 2x, negative y, negative z, and negative 16. And now we're just combining those to get a new equation here. So we get negative x when we combine like terms, positive y when we combine like terms, the z cancels out, which is what our goal was, and then 3 minus 16 is negative 13. We're going to call this now equation A, because that's just a new equation. We're going like Roman numeral style, outline style. So we're going to pick 2 equations, cancel out 1 variable, call it A. We're going to do the same thing for the next step. We're going to pick 2 different equations, cannot be the same 2 equations, different equations, and cancel out the same variable. So we just canceled z, so now we have to pick 2 different equations. So we cannot pick 1 and 2. We could pick 1 and 3 or 2 and 3, but we just can't do 1 and 2 together again. So it doesn't really matter. Let's do equation 3 and equation 1, I guess. So to make that cancel out, let's take equation 3 here. Now, in order to cancel out the 2z that is in equation 3, we're going to need a negative 2z. So to make that happen, we're going to multiply, I think I said equation 1. We're going to multiply it by negative 2, because then we'll take this z, and it will now be negative 2z, and that's what we want, so it cancels out with the positive 2z that's in equation 3. That looks hard to read. Let me rewrite that. So we're doing negative 2 times equation 1. So equation 3, we can leave it alone. We're just rewriting it here. And then here this is negative 2 times equation 1. So that's negative 2x, negative 4y, negative 2z. Remember, we're multiplying by negative 2. 3 times negative 2 is negative 6. So now we are combining those 2 equations to get our new equation B. So we get negative x negative 3y. The z canceled out. Remember, that's what we wanted. That's 0 now. Equals, and that's 3. So now we're going to do the last step here of canceling stuff out, is we're going to combine those new equations, equation A and B, and we're going to cancel out another variable. So now it's just like the old substitution that you learned in Algebra 1 that we did in the previous lesson. We're trying to eliminate something here. So between equation A and equation B, they're almost the same. X will cancel out pretty easily if we just change one of these negative x's to a positive x. So let's do, we'll leave the first equation, we'll leave A the way it was. That's negative x plus y equals negative 13. And then for equation B, to cancel out the x, we need to multiply, we got to change that sign, so it's a positive x. So we're going to multiply negative 1 times b. Multiplying that negative times this equation B gives us positive x, so that they cancel out. That's our goal. And then negative times negative is positive 3y. Negative times 3 would be negative 3. We're combining those like terms here. X cancels out. Y, that's 4y. Y plus 3y. And then negative 16, which means y equals, divide by 4, you get y equals negative 4. So all we need to do now, we know what y is, so we're going to plug that in, just like we would have in our last lesson about elimination or substitution. We're going to substitute it back in to either of these two equations. Going back into equation A or equation B, you get to choose. Let's go into equation A. We're going to substitute y equals negative 4. So in equation A, if y is negative 4, that means we have negative x plus negative 4 equals negative 13. Just going into equation A. You could have gone equation B. You'd get the same answer. So let's add that 4 over. That's negative 9, which means x equals positive 9. So now we have x equals 9, y equals negative 4. X equals 9, y equals negative 4. We're coming back up here to the top. Pick any of these equations that you want. I usually choose the one that has the numbers I like the most. Therefore, they're usually the smallest numbers. So let's take equation 1. And we're plugging in those things that we just wrote. X equals 9. So instead of x, we're writing 9. Instead of y, we're plugging in negative 4 there. And z, we're keeping. Now we're going to solve this out. That's 9 plus negative 8. I guess I should have wrote minus 8. Plus z equals 3. 9 minus 8 is 1. So let's subtract the 1 over here. So we get z equals 3 minus 1 is 2. So our final answer, now we have the 3 variables. When we had x and y, we wrote it as an ordered pair. Now that it's x, y, and z, we write it as an ordered triple. It just goes in order x, y, z. So x is 9, y is negative 4, and z is positive 2. So that's a lot of work by hand. The hardest part is keeping it organized. So that's what these boxes are about. You need 3 lines per box. Sometimes the bottom row, the bottom box, you need an extra row in the bottom boxes, but usually you should have that because you're at the bottom. So that's how I set it up. Now for the easy part, if you have a graphing calculator handy, your calculator has these built in, has a solver for it. It's right here in equation. So main menu, let's go to equation. And for this one, we're going to go to simultaneous. It's actually the same thing that we did in our last lesson when we showed the calculator how to do a system of equations, but this time we have 3 unknowns because it's x, y, and z. So it just gives you this. This is like a matrix. This is another way of calling this. But we're just typing in the coefficients. So 1, 2, 1, 3 for that top equation. Coefficient of y is 2. The coefficient of z is 1. And then this last column is the number that goes by itself. It is important that it's in that order, so when you type it in, everything's just lined up. It's easy to go, and you can just type. And then our last number here is 16 for the second equation. And then third equation would be 1, 1, 2, and then the answer by itself is 9. So as we're solving that out, or after we type it in, we just hit solve, and then 9, -4, 2. Same answer. Quick, easy way to check. Or if you have your calculator handy and you don't want to do the work by hand, the calculator can kind of do it all. So just another comment before we do another example. Anytime you get at any part of the equation where 0 equals 0, that means you've got infinite solutions, or 1 equals 0, that means no solutions. If that works out any part of your work. Alright, so for this next one, same process. We're going to label them equation 1, equation 2, equation 3. And then we're going to choose some equations to cancel out a variable. So I'm looking at these. A would be super easy to cancel out. So would B. That would be super easy to cancel out here. Let's go ahead and choose, let's cancel out the A's first, because I saw that first. And then also I'm looking at the B's would be easy to cancel out using 1 and 2, but using equation 3, that'd be a little bit harder. So it's kind of up to you. You know what, let's actually let's cancel out our B's, because then I'll show you a little bit harder way to handle these when that happens. So to cancel out B, we're going to take equation 1, and then we just need to change the sign right there. So negative equation 2. And you could have done that the other way around if you wanted to. You could have done the negative with equation 1. That would have worked. Equation 2 times the negative, so everything's just changing here. So the -3 and the -12 turn positive. Add those together. -8a. B cancels out. +8c. And then 28 and 12, that would be a -16. Alright, so again, we canceled out B, so we need to cancel out B now in the other equations. Let's do equations 2 and 3. Just can't do 1 and 2. Doesn't matter which ones we do. We have to use the one that we did not use before. We haven't used 3, so we have to use 3. Alright, so if we're canceling out the same letter, the same variable B, this time it's not an easy, oh, I just need to multiply one of the equations. You have to multiply them both. So we need a number that 6 and 4 can both multiply to equal. That would be 12. So to get 12, we need to multiply times 2 and times 3. 6 times 2 is 12. 4 times 3 is 12. Just remember we need a negative, so let's do a negative 3 here. All right, so now 2 times equation 2. That would be 8a, 12b, negative 6c, and negative 24. And now negative 3 times all of this. That'd be negative 3a, negative 12b, positive 6c, and then 18 times 3, 54. And it was a negative times a negative, so it's positive 54. So combine, we get 5a, cancels out. Ooh, that cancels out too. So that might seem weird. Then we get 30. That's actually a good thing because now we have a super easy equation to solve. Right here, just divide by 5. And we get a equals 6. So if a is 6, that helps us out because now we don't need to combine these two equations. We already have one answer. So take that one answer and plug it into the equation that has 2 variables. Remember, you're always just going to the next one equation that has one more variable than the previous. So we can plug 6 in right here. So that's negative 8 times 6. 6 times 8 is 48. Add the 48 over. And then divide by 8. We get C equals 4. So again, now we have 2 answers. We have A is 6, C is 4. We're going to take both of those answers, A is 6, C is 4, up to the top. Plug them into any of these equations you like. Equation 3 has the smallest numbers, I think. So I'm going to go with that. So that's 6 plus 4b minus 2 times 4 is 8. Six minus 8, that's negative 2. And add the 2 over, so that's negative 16. So 4b equals negative 16, so divide by 4, we get b equals negative 4. So again, we finish this with our ordered triple. A is first, we got 6. Then goes B, which is negative 4. And then C, which was positive 4. And again, we can do all of this with our calculator. So if we just type in all these numbers that we started with, and it's already in order, that's the way that we wanted it. Type all the coefficients. All right, so we've got everything typed in. Press solve. We should get the same thing. 6, -4, 4. Perfect. Okay, so we already talked about this a little bit, but on that previous slide, we said anytime we get 0 equals 0, that's infinite solutions, or 1 equals 0, you get no solutions. So that would happen anytime things cancel out. So this one, when we combine equation 1 and 2, now here's the second part to this, that this is actually easy because we already have an equation that does not have x in it. So we're actually just not doing anything to equation 1. We're just going to call it equation A, or sorry, equation 3. We're just going to now call it equation A because it's already a 2-variable equation. So now we need to take the other equations, 1 and 2, and we're going to combine them so that we cancel out x. Since this equation, equation 3, or A, as we call it now, does not have an x, we need to cancel out x. So to make that happen, we just need to subtract one of these. Doesn't matter which one. I'll do the second one because that's typically what I do. So equation 1 stays the same. Equation 2, we're multiplying by a negative, so that's negative x, negative 3, negative 9, and 0. So when we add those together, x canceled out. That's 0, that's gone. We get negative y, negative 5z, and 0. And we would call that equation B. So to finish this, remember our next step is to combine these so that another variable cancels out. So if we just combine them, we don't even have to add or multiply. We don't have to multiply by anything, we just have to add them together. We have y plus 5z equals 0 and negative y minus 5z equals 0. So you're actually going to see, obviously, both variables cancel out. So we get 0 on the left equals 0 on the right. We talked about that. 0 equals 0. The way I remember that 0 equals 0, when you have the two zeros, like 0 equals 0, you put them side by side, that's the infinity symbol. So 0 equals 0 means infinite solutions. Now, your calculator will also give you a different error code for infinite solutions versus 0 solutions on your calculator. So let's type these in. That'd be 1, 2, 4, 0, and then 1, 3, 9, 0. And then, since there's no x here, we're going to type a 0 in that spot. And then a 1, then a 5, and a 0. So now when we do solve, we're going to get an error. It says MA error. And from solving it out, we already know that that is infinite solutions because we already solved that part out. Now for no solutions, let's go ahead and see if we can just get there while we have the calculator out, just do that first. Remember, if any of these were missing, you just fill in a 0 in that spot. So this should be a no solution. It just gave us a MA error. Must be a different calculator that gives the unique answers based off of what it is. So again, we got an MA error, so we don't know if it's no solution or infinite solutions. So we're going to solve this out by hand to figure out what it is. Same process, equation 1, equation 2, equation 3. We need to cancel out a variable. The z's will be the easiest ones, I think, to cancel out. So if we use equation 1 and equation 2, to make the z's cancel, we have a -2 and a +1. We just need to make that +1 turn into a +2, so we'll multiply by 2. So then we would have a -2, +2. So that's 2x minus 8y plus 2z equals 6. And equation 2, we leave it alone. Combine. And now we're going to do the same thing. We can't use 1 and 2. We have to use the one we haven't used yet, so we have to use equation 3. And you can pick, it's going to be super easy to pick the one that doesn't have a coefficient or has a 1 as a coefficient, because then you can multiply it by anything. If we used equations 2 and 3, we'd have to get a common multiple of 6, multiply both equations. Here we just need to multiply equation 1, and we'll multiply it by a +3. So we'll have a -3z and a +3z. And then multiplying 3 times the first equation is 3x minus 12y plus 3z equals 3 times 3. And we combine these, so we get 10, -6, z canceled, and we get 11. And then sticking with our notation, this is equation A and B. We're going to combine those to cancel out. So let's go ahead and cancel out the x's, I guess. So we can take B, which is 10x and 5x. We just have to multiply by 2 to make them both equal 10. So we'll leave equation B alone. And then multiplying by 2, we get 10x. Multiplying by 2, we get -6y equals 10. Now, two things here. Number one, I forgot to multiply by a negative to make those cancel. Super easy, is you just change all your signs, and then you can do it. So if you forgot to change the signs, that's fine, just fix it. So that cancels out, that cancels out. So we got 0 on the left side equals, this time it's not a 0, it's 1. That's the difference between infinite and no solutions. Infinite would be 0 equals 0. No solutions, it would be 0 equals anything else. So the calculator does not tell you, but your work does. All right, that's it. Leave your comments, ask your questions online. Until next time.